In studying the characteristics of the minor planets, we said that very few spacecraft had visited an asteroid. Uh, then I started telling you the first two that were visited. Another one that was visited was the Japanese Muse C spacecraft, Hayabusa, visited an asteroid. It was a little small asteroid, originally had no name. It was numbered 25,143. And so they proposed naming it after a Japanese astronomer since a Japanese spacecraft was going to visit it. So the spacecraft was launched in 2003, headed towards the asteroid. Now, a couple things happened shortly after launch. There was a major geomagnetic storm, a major solar storm that actually sent hard radiation out that damaged the spacecraft. So it didn't actually operate quite as intended. The original plan was it was going to go up to the asteroid and collect a sample and bring back. That sample return didn't really happen. But the idea was you'd fly by this asteroid. There was a small asteroid passing near Earth. It would actually match speed with the asteroid and come up close to it and come back. All right, so they didn't know anything much about this asteroid. It was smaller than most. As it passed by close to Earth prior to this, then the Arecibo radio telescope bounced radar off of it and gave an idea that it's not exactly round, but that's about all we could find out about it. As the spacecraft started to approach, they noticed some weird things. First of all, it's an odd shape. Normally they're like potato shaped, but this thing has a big bend in the middle of it right there. And that big bend didn't seem to make any sense. They had these odd protrusions or bumps on it, but the most striking thing was there was no craters. The asteroids we'd seen prior to this had craters on them, and this one had no craters. And so it was like, well, what does this mean? As the spacecraft got very close to it, realized it was even more weird. It's just like a pile of debris. So you have this big pile of debris here and a very smooth region in between. And so that didn't seem to make sense. And so, in fact, this just looks like just boulders piled up on here. Boulders and dust. This is a pile of rubble. Okay. In fact, that's the idea. What we have realized is some of these asteroids are not really solid. They're just piles of rubble all pulled together by gravity. What happened? We know asteroids can run into each other. So one possibility is that two smaller asteroids slammed into each other with enough force, they blew themselves apart into a big pile of debris. That pile of debris pulled itself together into two separate clumps, which pulled themselves together to make this compound object right there, and then some of the debris and dust settled into that smooth region sort of at the neck of that. Okay, now this is what we think may have happened with this asteroid. Okay, now that's an interesting sort of idea or supposition. Okay, now we don't have proof of this, but it is an interesting supposition. This really throws a huge monkey wrench into all the sci-fi stories about what do you do if an asteroid is headed towards Earth? Well, you just send a missile up and blow it up. Problem is, if you just blow it up, its own gravity can pull itself back together again, and then you haven't really done anything. Okay, unless it hits Earth in the blown up stage instead of all back together. And then that's potentially worse because instead of just hitting in one small spot and wiping out that part of the Earth, you have like a shotgun blast that wipes out an entire hemisphere. So neither way is a good idea. So that's why rather than blowing it up, the preferred strategy is to nudge it off course if at all possible. As I said, the Hayabusa spacecraft was originally supposed to be a sample return mission. And that did not work the way they intended it because the radiation damage from the solar storm fried the spacecraft enough that it wasn't working right. So here's a shadow. You can see a shadow here of the spacecraft on against the asteroid. And as it came in close, the idea was it would come in close and have this robotic arm that would reach out and grab a sample from the surface of the asteroid. Well, as it got close, it lost contact, and as far as they can tell, it just bumped the asteroid and bounced off. So they brought it in again to try again. It bounced and bumped, bumped off again. And so the idea was, well, maybe it worked, and so the asteroid took the long journey back to Earth, and really there wasn't any particular sample there. So it was not a successful sample return. Here's kind of a graphic here. Emily Lakdawala, who works for the Planetary Society and sometimes actually writes things for Sky and Telescope magazine and for Science News, had a number of years ago put together a graphic here showing some of the asteroids that have been visited by different spacecraft. And so you can see that Itokawa in here is this tiny little speck right there, versus some of the others like Gaspra and then also Ida. Okay, down here. Wanted to point out that the Itokawa asteroid was not the first one visited by a spacecraft. That prior to the Hayabusa spacecraft, or Musa-C as the Japanese called it, NASA had launched something called the NEAR spacecraft, which stands for Near Earth Asteroid Rendezvous. And it flew past a couple of asteroids, flew past the asteroid Matilda, which was a carbonaceous asteroid, meaning it's very rich in carbon, and then flew by the asteroid Eros. And so Matilda was a very large asteroid. Eros was another one of these odd-shaped asteroids. Looks almost, like a reclining seal. Had very soft craters in it, and so again, suggestive it's not really a fully solid body. So Eros, probably just a rubble pile, very, very shallow, smooth craters, indicative it's very soft surface, and it also has very low density because it has very little gravity that pulled on the spacecraft. Now, the NEAR spacecraft was really only designed to operate for a certain length of time and space, and so when it got to this object, it was at the very end of its life. And so what NASA did was it kind of put it into orbit around Eros and let the orbit gradually get closer and closer, and so it let Eros's gravity pull the spacecraft in. And so the spacecraft was very slowly pulled inwards. This had so little gravity, it didn't come in very much. And eventually, the spacecraft actually drifted down to the surface and touched it. Now, it was not designed to land on the surface, but this is where the Japanese got the idea of a sample return from. It was not designed, but it actually bumped into the surface and stayed operating for a short while thereafter. Now, interestingly enough, there was a fella that decided that he was going to file a claim with the government saying that he was claiming the asteroid as his property and declared it a spacecraft parking facility and sued NASA for parking fees. And as you can imagine, the lawsuit didn't go anywhere, but your tax dollars at work defending against a frivolous lawsuit.